Hello viewers, in today's session we are going to discuss these two indefinite integrals using the concept of reduction formula for the integral that is tan x raised to n dx, right? So here we are going to derive the reduction formula for this indefinite integral, and then with the help of the reduction formula derived for this integral, we'll find out the values of these two indefinite integrals, right? So let us call this integral as in, right? So here the integrand is given by tan x raised to n. So let us first write this integrand as here we can write tan x raised to n minus 2, and here we can multiply this expression with tan square x, and here we have dx, right? So here tan x raised to n can be written like this, that is tan n minus 2x times tan square x, so that when we add these two exponents, then minus 2 and plus 2 get cancelled, and we'll again get our original integrand, that is tan x raised to n. So now let us make use of an important trigonometric identity, that is 1 plus tan square x is equal to secant square x, and we can now write tangent square x is equal to secant square x minus 1, right? So now we can replace this tan square x by secant square x minus 1. So we have now integral tan n minus 2x, and here we have secant square x minus 1 dx. So now multiply here by this quantity, that is tan n minus 2x times secant square x dx, and then we have another integral, that is tan n minus 2x times 1, that is tan n minus 2x dx, right? So now our integral in is given by the difference of these two integrals, right? Now this integral is simply given by replacing this n by n minus 2. So if we replace n by n minus 2 in this integral, we have this one, that is integral tan n minus 2x dx. So we can now replace this integral by I n minus 2, and here we have this indefinite integral. So in order to solve this indefinite integral, we'll make use of the method of substitution. So here we'll make this substitution, that is say u is equal to a tangent of x, so that du over dx is given by d by dx of tan x, that is secant square x. So we can now write du is equal to secant square x dx. So now we can replace this secant square x dx by du. So now we have I n is given by the integral u raised to n minus 2, because we are taking tan of x, that is tangent x is equal to u, and here we have a du, and here we have I n minus 2. Now this is a simple integral, and using this standard result, u raised to m du is given by u raised to m plus 1 over m plus 1, right? So here we have in is given by u raised to n minus 2 plus 1 over n minus 2 plus 1 minus in minus 2. So now we can write here u raised to n minus 1. 1 minus 2 is minus 1, and here also we have n minus 1, and here we have I n minus 2. Now replacing u by tangent of x, we have in is equal to tan n minus 1 x divided by n minus 1, and here we have minus I n minus 2, right? So this is our required reduction formula for in. So now using this result, we have to evaluate these two integrals. So let us take this one. So here the integrand is tan raised to 4 and x dx. So here we have to find out the value of I of 4, right? Because if we replace n by 4, then we have our integrand as 10x raised to 4, right? So let us substitute n is equal to 4 in this result, right? Because we wish to find out I4. So taking n is equal to 4 in this result, we have I4 is given by tan 4 minus 1x, and here we have 4 minus 1, and here we have 4 minus 2. So now we have I4 is given by tan cube x, and here we have 3, and here we have I 2, right? 4 minus 2 is 2. So now to get the value of I4, we need to find out I2, right? And I2 can be obtained by taking n is equal to 2 in this expression. So we can take n is equal to 2. So we have now tan square x dx. So I2 is integral tan square x dx, and we can find out the value of this indefinite integral by using this identity. Tan square x is given by secant square x minus 1. So here we have secant square x minus 1 dx. So now we have integral secant square x dx minus integral 1 dx, and here we can use the standard result. So integral secant square x dx is simply tan x, and here we have x, right? So now the value of I2 is given by tan x minus x. So now the value of I4 can be written as tan cube x over 3 minus, here we have minus tan x minus x. So we can now write I4 is equal to tan cube x over 3 minus tan x plus x, and here we'll write the constant of integration as c. So now let us find out the value of this indefinite integral. So here we have tan x raised to 6. So here we have to find out the value of the integral, that is I6. So here if we take n is equal to 6, then the integrand is tan x raised to 6. Now let us substitute here in this reduction formula, that is the value of n as 6 and 4, right? So first we'll substitute n is equal to 6 in this reduction formula. So we'll have this equation, that is I6 is equal to 10. Here we have 6 minus 1 5, and here we have 5 in the denominator, and here we have I 6 minus 2, that is 4. So let us call it equation number 1. Now let us substitute n is equal to 4, right? Because here we want to eliminate I4, right? So taking n is equal to 4 in this reduction formula, we have another equation. So we have I4 is given by 10. Here we have 4 minus 1 is 3, and here we have 3, and then we have I 4 minus 2 is 2. So let us take this as equation number 2, right? So now from these two equations we can eliminate I4, right? So what we will do, will substitute the value of I4 as this expression in equation 1. So we have I6 is equal to tangent 5x over 5 minus here we have tan cube x over 3 minus I2, right? So we have tan 5x over 5 minus tan cube x over 3 plus I2, right? So now we have already calculated the value of I2. I2 is integral tan square x dx, right? So substituting this value of I2 over here, we have now I6, that is the value of this integral is given by tan 5x over 5. Then we have minus tan cube x over 3, and then we have here a tan x minus x, right? And here we'll also add the constant of integration as c, right? So the required value of this integral, that is tan 6x, is given by this expression. So we can see that we can easily find out the values of these indefinite integrals using this reduction formula. So here it is important to note that the value of this integral can also be evaluated by taking n is equal to 2 in this reduction formula, right? So if we take n is equal to 2 in this equation, then we have I2, and I2 is given by integral tan square x dx, right? And we have calculated the value of this integral by using this identity, but we can also find out the value of integral tan square x dx by using this equation. So here taking n is equal to 2, we have I2 is equal to tan 2 minus 1, that is 1, and here we have 2 minus 1 1, and here we have I 0, that is n is 2, so 2 minus 2 is 0. So here we have simply tan x, and I0 is given by this expression. So this is integral tangent, and here tan x is raised to the power 0, and here we have a dx. So we have tan x, and tan x raised to 0 is 1. So here we have 1 dx, that is tan x, and here we have simply x, because integral dx is equal to x, right? And here we can also add the constant of integration as c, right? So we can also find out the value of the integral tan square x dx by directly substituting n is equal to 2 in this reduction formula.